Assalamualaikum. We from group 6, we have to show how to answer question 10 correctly from the open book test questions. So the question is, an extreme skier starting from rest goes down a mountain slope that makes an angle of 25 degrees with the horizontal. The coefficient of kinetic friction between her skis and the snow is 0.200. She goes down a distance of 10.4 meters before coming to the edge of the cliff. Without slowing down, she skis off the cliff at an angle and lands downhill at a point whose vertical distance is 3.50 meters below the edge. So the question is, how fast is she going just before she lands? And draw the free body diagram. Okay, so this question have two parts, which is the first part when the skier is coasting down the slope, and the second part is after she skis off the cliff. So at the first part we use kinematic equation, and the second part we will use the conservation of energy. From the first part, we will use the kinematic equation to find the acceleration. Hence we can get the final velocity. So the final velocity from the first part we will use as the initial velocity at the second part. And if we substitute, we will get the final velocity just before she lands.
Okay, now we're gonna draw a free body diagram. Firstly, draw the line that represent the skier ski over the cliff. Next, draw the line that represent the skier normal force. The line is 90 degree from the first line. Okay, next, draw the line that represent the skier wake. It is 25 degree from the y component because the skier ski down the slope that 25 degree from the horizontal. Right, now we label all the forces on the free body diagram. This is normal force of the skier. This is the 25 degree. This is the skier wake. This is the kinetic coefficient of the skier. This is G cos 5. This is mg sin 5. Represent the x component. Okay, now we have labeled all the free body diagram.
Okay, so moving to next steps. Next we will search for the final velocity on the cliff. But in order to do that, first we must to search for the acceleration, and then we can bring out all the informations. First, v0 equal to 0 ms. The delta x equal to 10.4 meter. Submission of f y equal to may. We can cross that 0. Submission of coefficient force is 0.200. Okay. Fk equals to mu n. So we can search n plus minus mg cos 25 equal to 0. That equals to n equal to mg cos 25. So the kinetic friction equal to 0.200 times n. Okay, moving to the next step. In order to search for the force on x exponent equals to ma. So we can do this by mg sin 25 plus minus minus kinetic force equals to ma. Proceed. Mg sin 25 minus with 0.200 mg cos 25 equals to ma. here we can see that we can cross all the m. We can cross them. Left us with the g sin 25 minus 0.200 g cos 25 equals to a. So at this point we can search the value of a. So a equal to 9.8 sin 25 minus 0.200 times with 9.8 cos 25, and then a equal to 4.141 659 minus 1.77636, and we get the final answer for the acceleration is 2.3653 meter per second squared. Okay, here's we already have the acceleration. After we found the acceleration, we can search for the final velocity using the formula of v squared equals to v naught squared plus 2a delta x. Taking from the information above, we can already cross this 0 because v naught is 0 ms. V squared equal to 2 times 23653. We take from the acceleration here, time with 10.4, and then we get the final velocity is 7.014146 m over second.
Okay, now so we use the theorem about conservation of energy, whereby final energy is equal to initial energy. We assume that there is no loss of energy between that. So now we use the formula kinetic energy final plus potential energy final equal to the kinetic energy initial plus potential energy initial. Then we use the formula, this formula, since we have m at both sides, we can cancel them, and then we simplify it, become this. Then we substitute the value, whereby velocity final square equal to 7.014146 to the power of 2 plus 2 times 9.8 times 3.5. Then the final answer is 10.9 meter per second. Then the answer is the final velocity or speed before the skier land is 10.9 meter per second. That is the final answer. The velocity just before it reached the bottom of the ground.
Final end of our video. So I hope you guys enjoy today what we teach you today, and see you around.